Hi everybody, we're going to get started here again. Pretty soon we're going to do our lightning talks. We'll talk a little bit about that in a second, but first we'd like to hear from our diamond sponsors. First of all, if you guys could give them a great round of applause, couldn't do this without them. Thanks. All right. So first to the podium, we're going to have U-Turn Data.
Hey, good morning, everybody. I'm Adam Dillman. I'm the managing partner and founder at U-Turn Data Solutions. U-Turn is a Chicago-based advanced tier AWS consulting partner. We were founded in 2013 and had the honor of joining the AWS meetup for our first time in 2014. So we're very excited to be invited to be a part of this and to see so many familiar faces, and for the out-of-towners, welcome. Wish it was a nicer day. So a little bit quickly about U-Turn. Philosophically, we're a little bit different. We're really focused on changing your approach, changing the thinking of our customers, and it's pretty inherent in our name. Much like this is the Unconference, we like to think of ourselves as the Unconsulting firm. We do that in a number of ways. We really focus on getting work done. We're not big on PowerPoint decks, we're big on POCs. We do things like immersion days. We're working with AWS on developing a game day specific to the well-architected framework. U-Turn was one of 35 well-architected partners, launch partners at reInvent last year. I encourage you to stop by and hear David Matthews talk at 4 o'clock today on the well-architected and living well-architected, and definitely stop by our booth and pick up some information to get a free well-architected review. We've got a couple of events that are coming up I just wanted to tell you about if it meets your need or piques your interest. On 6/26, we're doing a webinar really specifically around Microsoft 2008 end of service, so talking about different migration paths for SQL 2008. On July 23rd at the Amazon office downtown Chicago, we're going to be doing a half-day event with Amazon, our partner cloudhsm, who's going to be upstairs with us in the expo, our customer CIO at Rising Medical talking about their journey to AWS. U-Turn really believes fundamentally, to use a baseball analogy, that we're really just in the top of the second inning. We believe fully that cloud can benefit just about every firm out there, and we also believe fully in teaching our customers how to fish. We'd love the opportunity to meet you, and hopefully we'll get a chance throughout the day, whether it's up at the expo or if you have an opportunity to hear David talk. We're really excited to be here. Have a great conference. Thanks very much for making it.
Hey everybody, thank you for being here. I'm Jason Woodrum. I work at Ahead. We're actually a born in the data center company founded here in Chicago in 2007. We started our AWS practice in 2013. About 5 years ago, we created a digital transformation platform that we refer to as DDP, and it's really about creating an overall framework for transforming your business. So looking at things like relentless automation, if we're continuing to do things with high-paid resources in a manual way, we're not being very effective. It's about integrating operations, so taking either APMs or enterprise monitoring and bringing that into the workflow and operating in an intelligent way. Scaled DevOps, so helping organizations build software and iterate and deliver that software faster. And it's about security as well. I don't know if there's a lot of security people here, but that tends to be the group that gets left out in cloud transformation. And security is very important to the overall success of your cloud journey. So security should not be an inhibitor. We should use the security group as a means of setting the guardrails and establishing how we develop in the cloud. And then lastly, enterprise cloud. So to us, it doesn't matter if it's on-prem or off-prem. We understand what it means to operate in a hybrid world, and you should operate consistently across that platform and eventually help our clients get to AWS as the ultimate goal. So I run a team of architects. A lot of us are going to be upstairs. Please stop by, talk to us, let us know how we can help in your overall digital transformation journey, and appreciate the time. Thank you.
everybody. Thank you for being here. Thank you to AWS. I'm Stephanie Lanning. I'm with cloudhsm. We're a global AWS leader as an ISV, one of 5 of the partners that have the migration competency. And what our platform does is it infrastructure discovery, helps you understand your TCO when you're moving to AWS, your performance requirements, takes a look at the applications. So really what it does is helps you from the journey from day 1 up until you migrate. Day 1, you're thinking about things like, what's it going to cost to move to AWS? What are my workloads going to look like? How am I going to get there? So our tool helps in every single step along the way. We are also partnered here with U-Turn Data Solutions. Adam, who spoke first, we are going to be a part of the follow-up events as well. We're upstairs with them. But for a partner like U-Turn, they leverage Cloudhsm for their own customers to make sure that their migrations are more accurate, more efficient, and really just to get customers to the cloud quicker, faster, and happier. So thank you, guys.
Awesome. Thanks again to our sponsors. And also want to give a big shout out to the speakers today. This is an all volunteer event, so everyone's just doing this on their own time. So I'd like to call up our first lightning talk. By the way, these are less than 15 minutes. There's no time for questions. So these are going to go very fast. So first we've got Jack Schlederer.
Howdy folks, my name is Jack Schlederer and today I'm going to be talking to you guys about running an enterprise level search cluster on Amazon's Elastic Container Service. All right, got to kind of do a double slide transition here. So what we're going to be covering today is how my company, Direct Supply, how we use AWS. We're going to talk a little bit about what our cloud vision looks like as we migrate into AWS. I'm going to talk about how that relates to how we built this ECS cluster. I'm going to give a quick intro to all of our technologies, which includes the Apache Solr search engine and a little bit about the rest of our tech stack. I'm going to talk about how we used to run our old Solr environment in our data center, the issues that we faced with that, all of its shortcomings, and some of its drivers of what made us want to re-architect it and build it out in ECS. And then finally, we're going to wrap it up with just a few takeaways about building distributed systems on ECS, of course. First, I want to talk a little bit about me. I'm a software engineer at Direct Supply. We are an e-procurement and healthcare equipment company up in Milwaukee, Wisconsin. We're at just the tail end of our migration into AWS. I say tail end, but really, it's an ongoing project. I'm fairly new to this. I only have 4 years in engineering, 2 years in cloud engineering, because we only started our migration about 2 years ago. And my passion is bringing open source technologies into the AWS cloud ecosystem and reaping all the benefits that open source can have. This is my first time speaking, so if it's a little bit rocky, please bear with me. Thank you. All right, so let's talk a little bit about what our cloud vision looks like. When we started our migration 2 years ago, our Cloud Center of Excellence, which is basically our enterprise architecture team, came up with these 5 tenets that we want to follow during our migration. Number 1, we want to use as much infrastructure as code as possible. We wanted our deployments to be 100% automated. We want to prefer immutable resources to mutable resources. So maybe you've heard of the cattle versus pets metaphor, where if something's going wrong on a server, we don't want to waste time logging into it, troubleshooting it, and then fixing it. We want to tear it down and have AWS spin up a new one. We want our platform to be secure by default, and ultimately we want to provide a platform as a service to our internal product engineering teams to let them spin up apps on AWS quickly, and while still following all of our best practices. I don't think anything espouses these 5 more than how we ran our Solr cloud on ECS. So now what's Solr? Does anybody, can I get a show of hands, who here is familiar with Solr? Couple people? All right, so this first line here is right from their website. It's a blazing fast open source enterprise search platform. It's part of the Apache Software Foundation, so what that means is completely free, completely open source. You can go online and download it right now and start running it on your laptop. Ooh. Sorry, I forgot to advance the slides because, there we go. All right, sorry about that. I'm just clicking the button on my laptop. So it's part of the Apache Software Foundation. Completely free, completely open source, like I said, maintained by an army of open source developers around the world. It's a document database. You interact with it mainly through REST API, which means it's super interoperable between languages. And it's populated via one of two main ways. So it can be populated from SQL Server or any other relational database. You give it a stored procedure to run, it imports it, creates documents out of it, and puts them into the search index. They can also be populated via direct updates. So you can just say, post, here's the document, add it to the index. There are two main installation configs, and I'm going to go into both in a little bit. Master and slave, which is the old version, and then distributed solar cloud mode, which is the new version. All right, so what do we do with Solar? Just a little bit about that. Solar powers the search backend on our e-commerce platform, so we're searching over 10 million products. We're searching over 200 million purchase orders, and purchase order lines, both are searchable on our e-commerce platform, and then 50 million invoices for those orders. That's only a subset of the invoices because it's way more than that. And we're doing this on the order of hundreds of customers. A little bit about the rest of our tech stack in the cloud world. Obviously, we use AWS as our cloud provider of choice. GitLab CI we use for CI/CD deployments, and we use the HashiCorp suite as well. So Terraform for infrastructure as code, Vault for secrets management. Oops. I'm not going to be able to get used to that. And Packer for building our Docker images and AMIs, one of which is our custom home-built Solar Docker image. So let's talk a little bit about what our old Solar environment looks like. This is very much the legacy master and slave configuration. So the diagram that you see up there, that block on the right represents the master, and then the two on the left represent the slaves. So the master is in charge of taking all the data updates, which means it's in charge of running those stored procedures on SQL Server and importing the data, and it's also the only server that accepts post requests to add or delete documents directly from the search index. So what that means is that the master is set up to replicate all of its data actively to the slaves, and then the slaves are what you query. So when you go online and go to our website and you type in wheelchairs, wheelchair, that search query is hitting one of the slaves. It's never hitting the master. So this is very problematic in a couple of ways. Number one, all of the data is not necessarily in memory. Solar is a read-optimized and memory-optimized system, so if all the data is not in memory, you run into performance problems. The master can't take queries and slaves can't take updates, like as I said before. You can really only vertically scale this system, which means that you can grow these boxes as much as you want, but it's non-trivial to add another slave. And it's impossible to add another master because the data can only be mastered in one place. So it's very painful to scale, and we also never really had a good backup mechanism. So if we lost a collection, search went down on our site, which made a lot of customers very mad. So the only way to rebuild that index was to run that stored procedure on SQL Server. It takes an hour and a half, so search is down for an hour and a half. Customers are mad for an hour and a half. So how do we fix all this? Well, the answer is we wrote up a Solar Cloud module. So this is, who here uses Terraform, first of all? So a lot of people, several, all right. So what this is consuming our Solar Cloud module. And a couple of things that I want to highlight here are the two in red, New Relic and PagerDuty. Those are built right into the module. So we get monitoring built right into this. So we always know we always know the state of our system. And then what's highlighted in blue is our Solar minimum healthy %. So this means that during a rolling update of the ECS service, it's going to try and keep 93% of the instances healthy. So if you see that third line, node count, 15. Oh, I'm so sorry, guys. So take a second, take it all in. What I said before, let it soak. So I'm not going to be able to get used to that. So, anyways, that third line from the top, node count 15. solar minimum healthy percent 93. So what that means is that we're going to have an ECS cluster with 15 tasks. And then when we do new deployments, it's only going to kill one at a time to spin up new versions, or to spin up new versions of the task, which is really great because that means we're never more than one container degraded at a time. So what does this exactly spin up? So this is our, got it this time. So this spins up exactly 2 ECS services. So what you see, those first 2 rows right up here, those are our solar nodes. Not all 15 are described there, but you get the picture. And then we spin up 1 Zookeeper ECS service. So Zookeeper, does anybody here have any experience with Zookeeper? So Zookeeper is a cluster coordination service that I'll get into in a little bit when we get to a little bit of the challenges of operating this. But what we also spin up is a file gateway that gets attached to all of the host instances and gets plugged in as a volume to all of the containers. That's used for backups, which means that when our backup trigger Lambda runs every night, it just calls the Solar API, Solar dumps all of its index data into the file gateway, and that gets pushed right onto S3. So now we're backing up and restoring indexes much quicker than before. So I'll get into that a little later too. In addition to that, we also get an application load balancer, which distributes requests across all the Solar nodes. And then we also get Route 53 service discovery for the Zookeeper nodes, which is necessary for Solar, and Route 53 names for our search endpoint. So essentially, you go to search.directsupply.com or whatever, and it'll hit one of these Solar nodes. All right, so now any node can service any request because of Solar Cloud. Index data is sharded and replicated, so there's always more than one copy of the data across the cluster. Everything is in memory now, somewhere in the cluster, so when a request comes in, it will automatically be shuffled to whatever node is best to service that request. Horizontal growth is easy because we can just make changes to that Terraform block to add more, take it in again, to add more nodes to the cluster. Indexes restored in seconds through the file gateway. And we also get auto healing, which means that if a node goes down, when it spins back up, ECS spins up another node, or another task, I should say. Solar will automatically push on to it the copy of the data that it lost, and it'll automatically rejoin the cluster. So we get all these thanks to ECS and Docker, which provides containerization for us, provides auto scaling. Speed of growing and shrinking is tremendously decreased now because the speed of spinning up a Docker container is much faster than spinning up an EC2 instance, especially at a size of R4, 4x large, or whatever we're using. Solar is easy to upgrade. We just make a change to our Docker image, rebuild it using Packer, and then force a new deployment, get a rolling live deployment and live upgrade. We actually did a live upgrade during our sprint review one time, and people were amazed. We also get auto reprovisioning of bad containers through ECS. So if one goes down, obviously it's auto scaling, so it'll just spin right back up. And then we even get more benefits through infrastructure as code and Terraform. So easy configuration changes, along the lines of a single line of code or a couple lines of code to make huge configuration changes. One-click deploys, you just run Terraform apply, spins up your infrastructure automatically, and you're good to go. Configurations are easy to read because ideally what's in your master branch of your Git project or whatever's in your trunk is what's out there in AWS. And then finally, simple to replicate. So you get really, really simple to replicate configs. And I've spun up, once we wrote our module, I spun up 2 to 3 more Solar Cloud clusters on the order of minutes. So a couple of gotchas that have bit us since we started running this. Zookeeper. So Zookeeper, as I said, is the cluster coordination agent. So Zookeeper is in charge of maintaining the cluster state, knowing what's going on inside of the Solar world, and making sure that every request gets shuffled to the right node. So if there's no Zookeeper, then there's no search, and there's no updates that can happen. So you're pretty much in a state like before where I said, if you lose a collection, then search goes down. So search, has gone down before due to this. So we've learned to add monitoring to our Zookeeper nodes, make sure that they have enough disk, make sure that we have CPU and memory alerts on them, and then the number of shards. Beware of growing data sets. We have to grow the number of shards to fit because Solar Cloud allows you to chunk the data up, so it would be silly to not take advantage of that and increase the number of shards as you go. All right, so a couple of takeaways. I think the one big takeaway here is running distributed systems on ECS through the use of Terraform, through the use of Packer, really, really simple and really, really effective. A lot of distributed systems rely on shared file systems, which can be simply provided through the file gateway. You get auto-scaling built right into the service. You can tweak and tune easily from your or just by making changes to your Terraform configuration. And you also get super replicable environments by that same means. So that just about wraps it up for me. Thank you so much. Thank you to Margaret for organizing the event and the rest of the team, of course, as well. If you want to talk more about this, come see me at the Unconference and the happy hour later today. Thank you so much.
Okay, I don't know about you, but I am blown away that that's one of his first times speaking. So there's no monitor up here, just so you know, so advancing those slides is rough, so thank you, Jack. Next up, we have Paul Kuliniewicz, and I love this title, with Cloud HSM, Frustration as a Service.
Hi, everyone. Let's talk about Cloud HSM. I do have slides. Yeah, that's fine.
Excuse me.
There we go. Yeah, let's talk about Cloud HSM. Clicker doesn't work. Cool. All right, so first off, what even is Cloud HSM? Should you use it? Probably not. If you are going to use it, what are you going to have to deal with? And like, what kind of frustrations are you going to run into? So, what even is HSM? HSM is a hardware security module. If you have sensitive cryptographic keys or something like that that you really want to keep secret, an HSM is a physical device that you put them in and it keeps them safe. It gives you an interface to encrypt and decrypt with the keys in there, but generally doesn't give you a way to get the keys out. And there's all sorts of like restrictions on how you interact with it. They're actually pretty frustrating in practice. Cloud HSM is an Amazon service that lets you use Cloud HSMs in AWS. It papers over a little bit of the frustrations of working with HSMs, but a lot of that does get passed on to you. It does, however, give you a way to set up a cluster of HSM instances that are able to replicate with each other, so you have some redundancy there, and that's pretty nice. So, should you use Cloud HSM? In general, no, you shouldn't. Use KMS. KMS is Amazon's encryption as a service. It lets you have keys that you encrypt and decrypt with. It works pretty well. Integrates with other AWS services, which is great. You can restrict access to the keys in KMS using IAM permissions. If you have an S3 bucket you want to encrypt, you can do that with KMS. And it actually uses HSMs behind the scenes. By default, it'll use a bunch of HSMs that are completely owned and operated by Amazon. But if you really want to say, I have my own HSMs that I'm using to store my keys, you can actually tell KMS to use your own Cloud HSM cluster as its backing store. So that way you can say, like, yes, I have my own HSM, and I'm going to let KMS deal with interacting with it. But if you really do want to integrate with Cloud HSM yourself, there are actually a couple upsides. It's possible to replicate keys across clusters in different regions, which is not a feature that KMS lets you do. It also gives you a way to export keys if you want to get keys out of the cluster. KMS does not let you do this. However, the trade-off is that now you're doing all the work to integrate with the HSM that KMS would normally do behind the scenes for you. What does that look like? Step one, you create the cluster itself. You get an empty cluster, all right? Now you need to create one and only one HSM in this cluster. If you create too many, you won't be able to initialize it, which is frustrating. Then you have to start over. So at this state, we have an uninitialized cluster. We really can't do anything with it. Not useful. To initialize it, we need to give it a TLS certificate. That's because interactions with the cluster are not done via the AWS API. We do them over the network from an EC2 instance that's running in a VPC. And it doesn't provision its own certificate, so we download a CSR, we give it to the folks who manage our internal certificate authority, they give us a certificate back, we load it into the cluster. You may have heard of ACM. There's no integration with ACM. You get to handle this yourself. So now we have an initialized cluster. All this means is that now we can connect to it over the network. We still can't actually use it for HSM kind of things because we need to activate the cluster, which is a different step. And like I said, to interact with the cluster from here on out, we're not using the AWS API at all. We start up an EC2 instance, we install the cloudhsm-client software, which is a server that interacts with the HSM cluster over the network, and then our application and the CLI tools will talk to that client daemon process, which then talks to the Cloud HSM cluster. So to activate the cluster, we use a command shell that is part of the client library. And essentially what we do, we log into the cluster using default credentials. Given this is a security-focused device, the default password is password. We change the admin account's password, and now we can actually do stuff with keys. We can create users, we can tell them you're allowed to do different things with different keys. It's great. Now you can start using it. You do have to manage the clusters or the users directly on the cluster. There's no integration with IAM. It doesn't integrate with third-party SSO systems, like if you have an LDAP server. You literally have to use the user management features of the HSM cluster, which is a pain. But now our cluster is activated. We can actually use it. We have user accounts. We have TLS working. We can add new HSMs as we want, and everything will be great. So how do we actually use this thing? I said we can't use the AWS API. We got our choice of 4 different client libraries to integrate with our application, and those will let our application talk with a client daemon, which will let us talk to the Cloud HSM cluster, which will let us use the keys. I'm only going to talk about the Java library because that's the only one I have experience with. The Java library documentation consists of a few bits of code samples that are on the AWS website. There's no Java doc that I can see anywhere. I've looked for it. Fortunately, the sample code generally covers the ins and outs of what you need to do. The one weird thing, if you're familiar with the Java API for crypto, this is a non-standard part, authenticating to Cloud HSM. To do that, you have to create this instance of a login manager class, which is unique to this particular client library. And then you log in with the username and password of a user on the HSM cluster. There's this first parameter that I've labeled whatever here. That's basically ignored. It's using like what normal HSM implementations would do. It's ignored except that if you give it too long of a string, you'll get an exception and it won't work. But otherwise, you can ignore it. But then once you do that, you basically use it like you would any other source of key material in your Java application. In particular, you can access Cloud HSM via a key store object. And when you put keys in there, they'll go into Cloud HSM. When you encrypt and decrypt with keys in there, that'll happen on the Cloud HSM cluster. So actually, like, kind of nice. The one gotcha is key stores identify keys with aliases, which are names that you give it. They're strings. Cloud HSM identifies keys using handles, which are integers that it generates on its own in some unpredictable way. These do not quite go with each other. So what the client library takes advantage of is that in Cloud HSM, you can also have labels on your keys, which are strings, and then when you try to use a key based on its alias in the key store, it'll look up the corresponding key by its label in Cloud HSM, and that's how it finds it. There's one catch to this. Labels don't have to be unique. In fact, the Cloud HSM documentation suggests that you can deliberately give the same label to multiple keys as a way to logically group them together. Do not do this if you're using the Java library because it doesn't say what happens when you try to look up a key and there's more than one matching label. What happens in practice, from what I can tell, is that you just get the oldest key that happens to exist and all the other ones are invisible. but that's not part of the documented API, so I wouldn't rely on that. So now we get to the features that look appealing but are actually bad. I mentioned at the beginning that there's some features that cloudhsm gives you that KMS doesn't. It turns out there's a lot of landmines when you start trying to use these. For example, cross-region replication, one of the really cool looking things that cloudhsm gives you. The idea is that you can have two or more different clusters, same region or different region, and you can synchronize the keys from one cluster to another. So that way you can have like the same keys in multiple regions, and you can just use whatever your local region's cluster is to do encryption and decryption and not have to worry about, well, what key is in US East 2 versus what key is in US East 1. One of the catches is that this only works for backup twins. And by that I mean, you can't do this with arbitrary clusters. One of the clusters has to have been created from a backup of the other cluster for various technical reasons I'm not going to get into. But you can probably manage that. Another catch is you can only synchronize one key at a time manually via the command line tooling. There's no automatic replication between clusters. So you have to know which keys that are in this cluster that you want to replicate to that cluster and go through them one at a time and say, copy this key from that particular HSM to this particular HSM. So you could still do that yourself. I mean, you'd have to write some scripting, but that's fine. The real catch is that there's no user replication between clusters. At all, full stop. You are responsible, if you're doing this, to make sure that your users are the same between each cluster. This is important because permissions are based on the numeric user ID that cloudhsm assigns to users when you create them. So if you copy a key from the left cluster to the right cluster and it says user number 4 is allowed to use this key, it's going to be user number 4 in that other cluster, whichever user happens to be user number 4. Yeah. Because it turns out that user management is actually like even worse than I initially said. Users do not exist at the cluster level. They exist at the HSM level. The command line tooling that you use to manage users is actually running the same command in parallel on each HSM instance that it knows about in the cluster. So it is possible even within a cluster, if you're unlucky or doing very bad things with the CLI, to get your users out of sync within a cluster, at which point you are probably in a lot of trouble. This is why it warns you, are you sure you're connected to every HSM in your cluster before I create this user for you? This is why. Exporting keys. That's another feature that we can't do with KMS. The promise, and this is how normal HSMs work, when you export a key, you don't get the key directly. You get an encrypted version of that key. That's because the HSM's whole job is to protect your keys. If it gives you a plain text copy of the key, it's no longer able to protect them. So you get a wrapped copy of the key that you can then import it into another HSM that has the unwrapping key. And that's how it protects the key even when it's outside of the cluster. I'm about to tell you how exporting works in cloudhsm. Here's a link to the documentation. I want to assure you that this is not a misreading on my part. This is actually how it works. You're not going to believe me. When you export a key, it wraps the key like you would normally expect an HSM to do, and then it immediately and automatically unwraps it with the same key, leaving you with an unencrypted key. A casual reading of the documentation might make you think that this would be an encrypted export because you have to tell it what key to wrap with. Yeah, it gets even weirder because you can specify different keys to wrap and unwrap with. The unwrapping key has to be outside of the HSM cluster, but it of course has to be the same key that is inside the HSM cluster that you use to wrap with. Otherwise, you will get an error because I can't decrypt the key. I have no idea why you would ever want to export a key this way, but it's there. Yeah. Another feature that I didn't mention before is Quorum authentication. The way Quorum authentication works is, suppose we have some operation and we don't want to trust any one individual user to be able to do this on their own because it's that sensitive. Quorum authentication lets us say, we need to have some quorum of users, M here, say that yes, you're allowed to do this before they can actually conduct that operation. And there's a larger pool of size N users who are allowed to do this so that you don't have to have every single user who has permission to do this to approve the operation because obvious operational issues with that. cloudhsm lets you restrict certain operations to quorum authentication, but it is a process. First off, Every user who's going to be in the group that can approve this has to have a public-private key pair and import their public key to associate it with their user in the cluster. These private keys are expected to live outside of the cluster, even though the whole point of HSM was to be protecting your sensitive key material. Okay. Let's say I want to do an operations protected with Quorum authentication. I tell the cluster to give me a token. That's a file. I now go around to M different users and ask them to sign that file for me. Again, these are crypto operations happening outside of the cluster. So now I have a token file and M signature files. I now get to write another file that describes all of the different files I've gotten up to this point so that the cluster knows what files I have. And then I give all of these different files back to the cluster to say, approve this token for me. And that gives me a blank check to run exactly one command that requires Quorum authentication. The catch is, at no point did I have to say what command I was going to run with this approval. I didn't have to say that when I created the token or when I was going around to the users collecting signatures. So they're kind of trusting me to do one thing and not do anything bad with that. And if I want to run two different commands, I have to go through this whole process again to get a second Quorum token. So that's kind of a pain. So to wrap up, generally, if you want to use encryption as a service in AWS, use KMS if you can. Only resort to cloudhsm if you have some kind of regulatory or compliance reason to use your own HSMs. And even then, try to just have KMS be the front end for your cloudhsm cluster instead of integrating yourself. If you do want the HSM specific features, understand how you're going to be able to use them because there's a lot of quirks and awkwardness, and be prepared for an unusual integration. Thank you.
Three. You are Bob Lee. There you go. Forward, backward.
There we go. All right, how's it going, everyone? My name is Bob Lee, and I'm a system engineer at Innova International. So I actually work on our DevOps team. We oversee, Innova is kind of like 50-50 on-prem and in the cloud. My team really oversees a lot of the on-prem architectures as well as the cloud architectures. The main project that I'm working on right now is actually our first fully cloud native application. So today we're going to kind of talk about some of the things that I learned while going through this process and by spinning up a brand new application in the cloud when the company that we were working for is really kind of starting to grow and evolve with that. So let's get started. So how many of you guys remember these? I know as a kid, I was growing up in a small town in Illinois, I know me and my brother and my sister, we had one of these in our backyard. We used to love going out, building sand castles. I would play with my trucks and just always have a great time playing in the sand. There was always one thing that I can distinctly remember my mom saying whenever we would go outside in order to play, and that was, be careful when you dig. And so growing up again in a small town in Illinois, we had critters running in our backyard. Over the course of the night, we would have cats or dogs or squirrels, or we would have any critters running through. And sometimes they would get into our sandbox and they would leave us a present or two. So I actually never knew at that time that advice that my mom was giving me as a kid actually translates over pretty well into the tech world, and it kind of shocks me. So I actually found that this really does translate over to cloud sandboxes as well. So one of the beauties of the cloud, and I'm sure everybody knows this here, is that environments are free to spin up, at least in the free tier, and they're very, very easy in order to spin up. Just the time that I've been up here, you probably could have spun up 20, 25, 50 AWS environments, and you could have all of those as a sandbox And the beauty of that is that you're really running the same services and you have access to the same services that are running in your production environments at your companies. Now that's a beautiful thing, and I definitely don't want to take away from that, but there are risks that come out of that too. Some of the other benefits that come out of that are really the rapid proof of concepts that can come out of this, and just the amount of testing that not only somebody on a DevOps team can do, but a developer, a test engineer, anybody that might be reading a blog that reads about a new service or a new package or a new way of doing things, that they're able to spin up a brand new environment and they're able to start testing. From a DevOps perspective or from an ops perspective, there's really no way in order to restrict people from doing this. Being on the DevOps team in Innova, we've had it so many times where people have come to us with a Sandbox environment that is their own personal account in order to show us a demo of something that they've built and that they want it right away because they were able to spin something up over the weekend. So that really made me realize that there's been quite a culture transformation that has happened here. So this is my second job out of college. My first company that I was working for was actually a massive 50,000 plus employee company that was very legacy environments, very old and antiquated architectures, very heavy use of the mainframe. Rack and servers, it was a lot of physical hardware. And what I realized there is that when a proof of concept was put together in that environment, there was a lot of red tape and there was a lot of bureaucracy that you had to go through in order to get those test environments set up. Now, to be honest, it was that red tape and that bureaucracy that made me start looking for another position because I wanted to move quicker. I wanted to utilize the latest and the greatest. I wanted to try the new packages, the new programming languages, and I didn't want anybody in order to tell me no on that. So that was really one reason why I kind of started looking for a new position. However, looking back at it and going through that experience, that red tape and that bureaucracy does help to enforce conversations that might not happen in today's world within the cloud. If you have to create 5, 6, 7 tickets and have 4 meetings with people in order to get a test environment spun up, the one benefit of that is that you're having conversations and you might have an interaction with someone that might have another idea, another way of thinking about things. There might already be something available in your environment that you're able to utilize instead of creating this brand new thing. So even though that red tape and that bureaucracy was there, I definitely understand that there's benefits of it. But now in the world of the cloud, everything is very different. Common complications that I've seen with Sandbox or dev type of environments is that they almost never abide to best practices or productionalized practices. What I mean by that is that so many demos that what I've seen or Sandbox environments that I've looked at or worked with, they're lacking infrastructure as code. They don't have configuration management tied to the servers in the accounts. Wide open security groups, that's one of the most annoying ones I always see, 0.0.0.0/0. No enforcement of HTTPS, and a lot of times you'll see just a single VPC with a single public subnet, and just really not the best practices when it comes to a productionalized system. And the biggest complication is that when one of these is spun up, you always hear, we want it now. We were able to spin up this proof of concept environment over a weekend, and we want this in our productionalized environment tomorrow. We wanted it yesterday. So that's one of the big complications that I've seen. I always laugh at this picture because it's so true, and it really hits me deep down a little bit, and it's really just with how quick it is in order to innovate and how quick it is in order to try out new things and new technologies now. That you can spin something up very quickly in dev, and then so often it comes to, all right, it's the DevOps problem, it's operations problem now, and we need it in our trial environment, staging, production, we need it in all of those, and you guys get to handle the Terraform, the configuration management, and all that. We don't want to know about that. So I always just laugh at this picture. So let's go into a real life example. So the project that I'm currently working on now, the project team actually found a use case for AWS Elasticsearch. They put it together by hand in a Sandbox environment that they had spun up within like our company account. And my team, the DevOps team, was actually approached the next day in order to be migrated into their integration environment. Well, so there were some challenges that came out of that. As I had said, I mean, we're probably a little bit less than 50-50 on-prem and in AWS, but by no means are we using every service that AWS has. Therefore, we don't really have everything productionalized. We don't have Terraform modules written for every service. So when these new services come out, there's a lot of hardening and there's a lot of productionalization that really has to happen that my team has to take over in order to get it moved in. So at this point, when the team approached us and said, hey, we're using Elasticsearch in AWS, check it out. Because we didn't have modules, we didn't really have a basis for any of this, we went to the Sandbox environment in order to take a look at what might be configured, because we could use that as a basis in order to write the Terraform and the configuration management and all of that. And what do you think we found? It was a little bit of a surprise. Again, I can remember, I will never forget in this particular situation, I went into the security group list and there was one. It was called Wide Open. It was used for the Elasticsearch cluster, the ECS clusters that were actually spun up in there. Everything that required a security group, Wide Open was used because it works. There was a single VPC and there was a single public subnet that was in there. Again, no enforcement of HTTPS, anything like that. It was just a very, very quickly spun up in a very quick architecture in order to demo Elasticsearch to us. So at that point, we looked at that and we really realized that, you know, there's some challenges here, because at that point they were able to, the team was actually able to prove to their management that, hey, Elasticsearch is great, look what we can do with it. We did this over the course of 2 or 3 days, and now we want it in our environment. So what we really found from this is that situations like this bring up unrealistic timelines, and it's really because of that. Because it's so quick to spin up a new environment and to try a new service. When it comes to teams wanting that in production, again, they just want it now, and those are really unrealistic. So there were many meetings that were happening at the manager level and even higher than that was saying, why can't we have this tomorrow? You know, my team was able to spin this up very quickly. You know, why are you saying that, you know, that we can't have this tomorrow? We can't have this today. What is your reason behind that? And there was just a lot of headbutting, like internal headbutting that tended to happen with that, when my team was kind of pushing back because we have our own workloads that we have to be working on. And then to kind of get broadsided by something like this, we just have to plan for it and then work it into our normal work. The hardest one in order to hear, and this one hurts me quite a bit, is that so we heard from, like, through the grapevine that DevOps was actually oftentimes refers to as a blocker of innovation, and that was mainly just because of we would have to build a project plan, we would have to put in tickets, we would actually have to plan for the work, and it was slower than what the software engineering teams or what the test engineering teams actually wanted to see, because we weren't able to spin it up that quickly. All of these result in just unnecessary internal conflicts. I always laugh about this as well, because same company, right? Same company, same goal, but there's just unnecessary headbutting that tends to happen there because everything has to happen so fast, which is quite a bit different from the first company that I was working for that did have all that red tape and the bureaucracy. So what have we done to limit this? So again, let me stress here, I mean, this is kind of really early on, and we've really just started hitting this pretty hard with these, with these new Sandbox environments and these proof of concepts. So we actually started to enforce development teams to write their own Terraform. They don't like to hear that. They generally don't like to hear that because that's another thing that they have to learn. But we've slowly been building out modules. We've been slowly putting together internal documentation in order to help the developers or the engineers to write their own Terraform. So we've really been enforcing them, we've really been trying to enforce them in order to do this during projects. My team will actually work as an intermediary and help them out with the modules and the changes, but we always like, in order to see the pull requests come through, we'll work together with the team in order to get the proper productionalized processes put into place. We've actually established architecture office hours that happen weekly. So these office hours are basically our principal architects. They're available in a room. And if you have a new idea for a new service, a new package, anything like that, it's been stressed to the entire tech organization within the company in order to go to those office hours first. Mainly just to start getting the correct teams involved very early on, so that way nobody is really broadsided, and we can kind of start building in time in order to perform the correct research or talk about any issues that what we might see that come up from that. We've also provided quasi-controlled dev environments, and what I mean by that is right now we still have a lot of work in order to do in this field. But if you request a sandbox environment from us, we will actually spin one up for you that is tied into like our direct connect gateways. It's tied into our networks already, so we're kind of limiting some of those boundaries that are there. So we're trying to give a little bit more of a controlled sandbox, if you will, as opposed to somebody just kind of going out, spinning up their own architecture, and then running with it from there. We've also found one of the biggest things that really helps is just to share our pains with the engineers. I've been shocked in order to find, like, if we have our weekly tech talks, and if we just kind of say, we had this issue, this is why we had our frustrations, that really resonates. So many times it seems like engineers will get riled up or they'll get angry, and if the other side doesn't actually understand those complications, that's when it kind of starts to spiral out of control. So really just like the continual just talking and just like the sharing of knowledge really has gone a long way. Now, like I said, this is really our first steps in order to help out with these problems, but we have a lot of work to do still in order to kind of lock these things down and really to help with these. And as Kelvin had said this morning as well, I love talking about this. Find me today. Maybe you have other ideas outside of these bullets that you have that you would love to share, or maybe you want to talk about like some of the tribulations of what we've had working on this project. I'd be more than happy in order to talk to you guys or anybody about that, and we can share the knowledge there. So with that being said, thank you so much, and enjoy the rest of the community day.
Sorry, some technical difficulties here. That's going to make life a little easier. There we go. See, okay. Hi, everybody. I'm JD. This is my quick version of dealing with mental illness, or how I learned to dislike myself less. I am a Drupal technical architect, which technically means I'm not an architect. I just know how to put together a Drupal site. If you want to tweet about this, I'm at JDDoesDev on Twitter. If you happen to be on any Slack that I'm on, I'm Dorf. Yeah, so thanks for coming. I like to start off with a big friendly hello, so hello. Hi. I also like to start with some disclaimers. I'm not a doctor. I'm not here to give medical advice. I'm not here to give any mental health advice. So anything I say is my own opinion. I'm not a lawyer. No legal advice coming from me. Again, my opinion. I tend to swear without thinking about it, so if anybody's easily offended by that, I apologize in advance. And I also have a couple of personal stories that I tend to share. So just a heads up on that. So why are we here? I don't mean the big why are we here, not trying to give anybody an existential crisis. I mean today. Me personally, I'm here to talk and have a conversation with you about something that's very, very important to me. I hope that you're all here, not only because it's the only track going on, but because you want to have a conversation, you want to learn something. Something else that I'm hoping to do is maybe share my story and hope that my story helps somebody the way that someone else's story helped me. So let's have that conversation. You go first. I have a couple questions. I like to know who I'm talking with. So how many of you are developers, work with tech, programmers, even designers, anything like that? A lot of hands going up. Okay. Are any of you account managers, project managers, producers, anything like that? A couple. Is anybody here in HR? You two, okay. I'm glad you're here, because normally when I give this kind of talk, there's not a lot of HR professionals, so I'm really glad that we have a couple here. Any of you at the upper management level, the high C-level, VP, presidents, managers? I see one hand, maybe two hands over there. Okay, so we have a good mix. That's great. You may be asking yourself, who the heck is this? Because I don't think I know any of you in here, which is okay. I like meeting new people. So as I said, I'm a Drupal developer. I've been doing Drupal and PHP for about 6 years now. I also help organize MidCamp, which is the annual Chicago Drupal camp. So big thanks to the event organizers. I know how hard this is. So you guys are doing amazing. I also help organize the Chicago Drupal meetup. And before I did all this, I was a paramedic for about 10 years. So a little bit of a change of career. Also, I have mental illnesses. In case you couldn't tell by the title, I have a couple mental illnesses. So I'm going to go down the list of what I have. PTSD, ADHD, anxiety, and general depression. So what are those? Major depression. Major depression is marked by inability to enjoy life and feelings of sadness, guilt, or low self-worth with symptoms expanding over 2 weeks in a row. That's the textbook definition. Anxiety disorder. Anxiety disorder is feelings of, well, anxiety, being frightened, being, you all know what anxiety is. But you see that little green dot there? That's the amygdala. That's your lizard brain. It has 4 basic functions. Fight, flight, feed, breed. Mine likes to say run away all the time. And I have the same reaction that somebody might get while being mauled by a bear when I walk into a social situation. PTSD. This one is inability to recover from witnessing or experiencing a terrifying event. One thing that made sense to me, or helped make sense to me, was when a psychologist explained it to me in computer terms after he asked me to fix his printer. He told me to think of your brain as a computer. Are we all there? You've got your CPU, your RAM, and your hard disk. So your RAM is your short-term memory. Hard disk is your long-term memory. What happens with PTSD is your event gets stuck right in that short-term memory. And it's really quick back and forth to the CPU. It's running, it's running, it's running, never moves back. So the event's stuck in your short-term memory. It's really easy to relive it. Any sight, sound, smell, anything can make you relive that event. It made a lot of sense to me. Hopefully it makes sense to you. ADHD, inability to focus or pay attention and leads to difficulty in academic, social, and emotional growth. For me, I used to daydream a lot as a kid. I didn't do homework. I'd always do tests. I couldn't focus on anything, and it was just, hey, go burn off some energy or pay attention, and that didn't work. Now, on paper, I haven't had mental illness that long. In reality, I have, but on paper, I haven't. It took me a very long time to seek out treatment. I was in my early 30s when I decided to get treatment. But how did I get there? Well, I noticed that a lot of people weren't having as difficult a time with everyday things as I was. For a long time, I thought that was a normal. My normal wasn't normal, but it was to me. But then I noticed people were happy, people weren't getting upset, people weren't fighting, people weren't yelling, people weren't throwing couches. And then I kind of had an epiphany one day where, maybe it's not everybody else, maybe it's me. If your shoes smell like dog shit, maybe, or, I screwed that one up. If everywhere you go smells like dog shit, check your own shoes. That's how it should have gone. So, a series of events started off with a panic attack, going into college, just sitting in my car. I couldn't get out of my car, I couldn't go. There wasn't a test, wasn't a speech, nothing, to really be worried about other than building people, no. And I backed out and I kind of had a realization at that time, maybe this isn't right. So eventually I did something difficult. I got treatment, but a part of that was overcoming the stigma. So in case you didn't know, there's a stigma around mental illness. And that originates from centuries and centuries of people looking at people with mental illness as less than. Being grouped with criminals, just kind of swept under the rug, put in jail, maybe possessed by demons. Who knows? But it wasn't until about 1953 when treatment got kind of serious with the writing of the DSM, at that time it was DSM-1. And that's a book that's about this tall that has all the diagnoses of mental illness that there are. I think that the count right now, if you don't add modifiers, is about a little over 150. If you add modifiers, it goes way up to 600. And that's like depression, major depression, recurrent depression. There's a lot of them. I had one enemy most of this time. In case you can't tell, it's a mirror. This was the biggest thing that caused me the most grief. Every time I'd walk by, I hate you. You're a piece of crap. I don't like you. You're worthless. Nobody likes you. Every time I went in front of a mirror, every time I went to the bathroom, anytime I was in front of a reflective surface, and you know how many reflective surfaces there are? I'm looking at the glass here. There's a lot just in this room. So I accepted I needed help, though. After all those events, I finally said, you know what? It's been long enough. I need to do something about this. So I took the next step. Accepting I needed help is a really difficult thing. A lot of people don't make it to this point. I got treatment. I see a therapist. I take medications. I am a huge fan of Better Living Through Chemistry. So my happy pills are my happy pills, and I keep them with me. And life is good. Well, not good. Life is better. I don't hate the mirror as much anymore. The mirror doesn't yell back at me anymore. I'm able to do this. I'm in a room full of, I can't even count how many strangers here talking about some of my deepest things. But I got treatment, and it is great. And in doing so, I realized that those of us with mental illness are not alone. There's an organization that I work with called OSME, Open Sourcing Mental Illness. Has anybody heard of them? Well, now you have. I heard a couple of claps back there. Okay. It's a great organization, and I'd love to talk with you more about it, maybe in one of the unconference sessions. But in the tech community, we're not alone with this. A recent survey by OSME, that's one of the things they do, showed that 43% of all respondents to the survey, it was made available to several tech communities. It was self-reporting, US only. 43% of all respondents claimed mental illness diagnosis. On top of that, 19% of respondents claim that they think they might have a diagnosis, but they haven't been diagnosed. They think they have something. So either they're afraid because of the stigma to actually get diagnosed, or maybe there's a lapse of insurance, who knows, but they think they have it, they're not getting treatment. But with those numbers, we're not alone. Those of us with mental illness are not alone. I was sick for a long time, 30-some years, and I refused to admit it. It was just the way life was. But I did something about it. I didn't get close enough to the edge to really take that next dark step. But from my time as a paramedic, a lot of people I worked with did take that dark step. It takes more than one hand to count how many people I know who have died of suicide because they didn't feel that they could get treatment, or that they didn't feel that it was bad enough for them until it was too bad. But I admitted it. I admitted there was something wrong, and I give the tech community in general a big big thanks for that, because this is a very inclusive community, and it's amazing. Because of that, because of events like this, I've become stronger than fear. I get up, I tell my story. I hope that this leads to other people telling their stories, or at least having conversations, opening up, talking to somebody. I don't mean this, and you can be too, as getting up on a pedestal, hey, be like me. Please don't be like me. I mean, there are people who will listen. There are options out there to talk to. If you feel that you have some form of mental illness, or you're just worried or need somebody to talk to, there are resources out there. One of my favorite, they're not paying me to say this, although they should, is psychologytoday.com. It has a therapist finder, which is very granular. It's a very faceted search, where you can go down to the gender of the therapist, to their religious preference, things that will make you feel more comfortable talking to them. So if you need help, get help. There are resources available. Haven't had a lot of time here, so I would like to continue this conversation. Meet me up in the lunchroom, not the bike racks. We're not going to fight. We're going to have a good time. And we'll get it on conference going, just a round table. I'm not trying to sell anything. I just want to talk. So thank you all for listening. Thank you for having me, and thank you for your time.
Okay, let's see if this works. Is that working? Any signal? Okay. Magical present button. There we go. Hi. My name's Andrew May, and I'll be talking about running containers in AWS. Now, this originally was a much longer talk, presented at the Columbus meetup, where I attend, and I've cut it down to a lightning talk. Hope I don't keep you too much through lunch. So we're going to start talking about ECR. So we need somewhere to store our containers when we run them in the cloud. And this is a container registry that's available in AWS. Now, one of the nice things about ECR is it's in every AWS region. You want your container images to be close to where you're going to run them, because then it's fast to pull them down and start them. The images in ECR are secured with IAM policies, and we have a repository per registry. So a repository stores a particular image, and you can have multiple versions, and then the registry is the service as a whole. You can have lifecycle policies here to keep your images clean, so you may generate different images on each build. This is going to take up a lot of space, and you pay for the amount of space you consume. Lifecycle policies will clean those up. When you want to use these images, you log in using the AWS command line interface, and then you use standard Docker pull and push commands. And then your images, you tag them with a prefix that's the repository name, and that name is made unique by including your account ID and the AWS region they belong to. So if you're going to run your service in multiple regions, you probably want to push it to a repository in each of those regions you're going to run it in. Okay, so we got some images. Now we want to run them. Let's talk about orchestration. Why do we want orchestration? Well, this is going to give you a whole bunch of things. It's going to give you configuration for your Docker containers. Now, you may have used Docker on the command line. You've said Docker run, and it's applied a whole bunch of command line arguments. Well, the orchestration is what's going to manage that configuration for you. The scheduling. Well, you want to run a bunch of these different containers. You want to run them on different instances. You perhaps want to run them at particular times. Well, that orchestration is going to control that for you as well. Deployment. Well, I've got a new version of this service I want to push out. How do I do that? I want to make sure I don't have downtime. Scaling out under load or other metrics. Handling volumes. Perhaps you've got some persistent data you want to attach to your container and you want to manage that. Secret management. Perhaps I've got a password that I need to connect to a database and I want to secure that password. High availability. Obviously, we're in an enterprise situation here. We want our service to stay up. And then load balancer integration, because as soon as we're running multiple copies of our service, we need to manage that access via a load balancer. In AWS, we really have two main schools of orchestration that are managed by AWS services. There's ECS, the Elastic Container Service, and that includes the Fargate runtime engine, and also Elastic Beanstalk can use ECS under the hood. And then there's EKS, which is a Kubernetes managed cluster. Now, I'm not really going to talk about the Beanstalk. I wouldn't really recommend it. If you're going to run something on top of ECS, you might as well use ECS directly rather than having the abstraction of using Beanstalk. Now, ECS is the Elastic Container Service, and it's pretty much the original AWS service for running containers. Now, it started out actually as the backend for Lambda functions, so it actually was made available as a separate service the year after Lambdas were announced at reInvent. And the service itself is free. You just pay for the resources that you use alongside the ECS control plane itself. So this would be EC2 instances where your actual containers run, or the Fargate runtime engine that I'll talk about in a minute. There's also things like load balancers and any back-end services that you use you'd be paying for. One of the big benefits of ECS is its strong integration with other AWS services. For example, you've got IAM integration. This might be permissions down to a container level. Perhaps you've got multiple containers on the same EC2 instance. One of them talks to Dynamo, another talks to S3. Well, you don't want to grant them the sum of those permissions. You want the containers to have their own sets of unique permissions. Strong integration with different types of load balancers, both classic ALB, the classic load balancer, application load balancers, and network load balancers. And then auto-scaling capabilities that work very similar to EC2 auto-scaling. Now, this is what a cluster looks like in ECS. It's a bit of a mess. Honestly, it looked cleaner, and then they added Fargate, and they just sort of bolted it in here one day. And so some of the terminology here is kind of confusing. So ECS can use either EC2 instances or Fargate to run your containers. And here they use the terminology container instance, which is also referred to as an ECS instance. And that's really just an EC2 instance that's been registered with your ECS cluster to be able to run containers. There's the term a task, and a task is one or more running container. Typically, there's one primary container in that task, and then possibly sidecars. And then tasks are defined by task definitions, and services are groups of long-running tasks. Now, a bit more about task definitions. This is really your template for how your tasks are going to run. As I said, it's one or more container. Typically, it's pointing to an image in ECR, but it could be Docker Hub instead. When one of these starts, an ECS agent is going to pull down the image from the repository and start it up using the configuration supplied in the task definition. The configuration includes things like port mappings, memory, CPU, and also things like IAM roles and a bunch of other stuff you can configure. And importantly, these are versioned, which is important when we want to deploy a new version of either the configuration or the image that it references. I mentioned services. This is an example of multiple services running in the same EC2 instance. Imagine there's multiple EC2 instances here running other copies of these. And you can see that all of these are long-running services. They're web services. Perhaps they want to use port 80 on their container. Well, we've got some issues here. Firstly, they can't all use port 80 on the EC2 instance. In fact, none of them can because they're not running as root. So they need to be mapped to a port on that host. Now, one of the nice things that they added when they added ALB integration was the ability to say, just assign port 0 on the host. And that just means I'll give you an ephemeral port, and I'm going to figure it out for you, and I'm going to map that random port number into the ALB target group, and I'm going to maintain that mapping for you, so you don't have to worry about uniquely specifying different ports for your different task definitions. And if you've got something like Route 53 in front of your ALB, you can use different domain names to route requests to these different services running in your cluster, all sharing the same load balancer. Now, some other ECS benefits. This can all be provisioned using CloudFormation or something like Terraform as well. And that can be the same tool that you're using to provision all of your infrastructure in AWS, rather than using one set of tools to provision the cluster and another set of tools to provision your services. When you want to update a service, you just supply it a new task definition version, and it's going to do a blue-green deployment. So it's going to spin up a new version of your services, check that they're healthy according to their health check before it spins down the old one. So you should have no downtime when you do that. It's possible to use spot instances for your EC2 instances to save a lot of money in your cluster. And there's mechanisms to ensure that before the spot instance dies, it moves the images over to another server. And your metrics go to CloudWatch, and your logs can go to CloudWatch logs or other services. Now, I've mentioned Fargate a couple of times. This is a compute engine for ECS. It's what they would call a serverless option. Obviously, the servers, but you're just not managing them yourself. In this case, you have to specify directly the amount of CPU and memory that your containers are going to use. And here, these are fixed hard limits, so your container can't use any more of that. This is different than when you run on EC2, because if you run on EC2, then you can kind of under-provision or over-provision, and if there's spare CPU or memory available, it can use in excess of what you've specified. You're also fixed into more sort of specific ranges, like half a CPU or a full CPU. Networking here is always AWS VPC, so each container gets its own IP address. And scaling is similar to when you run on EC2 behind the scenes, but it's a bit simpler because you don't have to scale the number of EC2 instances that you need to run your containers. So why aren't we all using it? It's kind of pricey. It actually got a lot cheaper recently. It's still pricey. It's about the same cost as 70% utilized on-demand instances. And once you get spot instances or reserved instances, then the equation for using Fargate doesn't look so good. EKS is a managed Kubernetes service. Now, Kubernetes, if you don't know, is the predominant orchestration engine for Docker. It wasn't really the case when ECS came along, so that's kind of why they developed their own service. It's available in the different cloud platforms. I'd say the GCP offering is by far the most mature. The one from AWS and Azure both came out last year. So what does it actually manage in terms of Kubernetes? Well, it's going to handle everything that's in that master node instance area. And it's actually going to run 3 copies of those in a high available setup. Now, what does that mean? If you look down here at the bottom of here, the big downside here is this costs money. So it's 20 cents an hour, which is about $140 a month. Fine for an enterprise, a bit pricey for an individual. It also takes quite a bit of work to set up some of these steps you see here. If you don't want to go through all that pain, there's a rather nice tool from Weaveworks that uses a command line so that you can set up an entire cluster. In this case, it's setting up an entire cluster with a single command line. It generated a VPC. It provisioned the EC2 instances. You can do other things here, like install Helm directly into the cluster, or you could use an existing VPC. There's a lot of different options. Now, I would say using EKS without something like EKS control, it's a bit of a pain. It's a pretty new service. It keeps changing. Integration with other AWS services is a lot more work than it is with ECS because it's not an AWS product. And you tend to have to install a variety of different services in order to integrate with other AWS services. This is the entire information you get about an EKS cluster in the console. So there's absolutely zero information about the services running inside your cluster. So you have to go directly use the kube control commands to see what services are running or install some other dashboard. Very briefly, going to talk about a couple of other services that work around containers. So Cloud Map is a service discovery option in AWS. Now, originally, this was just service discovery for ECS, and this was entirely DNS-based using A records and service records. And then they expanded it more recently to add an API-based solution because not everything really fits into DNS. Not everything has an IP address you can shove in there. So with the API-based system, you can add things like S3 buckets, Lambda functions, a whole bunch of other things. So where that's useful is you can also then give them tags and query based on tags. So you might query give me my production bucket, give me my dev bucket. In a very simple example here, you've got service A calling service B, the front end calling the back end. In a traditional setup, the version of the second service that it's calling is part of the configuration, and that's statically configured. And if you want to change to the second version, you have to make a deployment. In the use case where you use Cloud Map, you're continually asking Cloud Map, before you make a call to the other service, give me the endpoint for that service I'm going to call. And so you can transparently in Cloud Map switch you over to the second version of the service without making a configuration change. Now, moving further on, we've got App Mesh. Now, this is a service mesh running in AWS. This is a very new and rather immature product. It's just been released. Now, service meshes are the big hotness in microservices these days. Now, like Istio, which is really the most popular service mesh, this uses the Envoy open source proxy. This runs in front of your containers. All of your communication goes into the proxy first and then goes out via the proxy. So that gives the proxy a lot of control over what your container can actually be talked to from and can talk to. This allows the proxy to do things like manage your connectivity. This can actually serve as a load balancer, so it can look up all the instances of another service it wants to talk to and send requests onto the service. And this might be managing which version of a service you call. It can also do things like canary routing, A/B testing. It can implement retry policies and circuit breakers, all without the service itself needing to know anything about what the proxy or the mesh is doing. It all is transparent to the service. Now, this integrates with Cloud Map and also other AWS services like CloudWatch for metrics and X-Ray for tracing. Again, a very simple example here. We've got service A talking to service B, of which there's multiple copies and multiple versions of B. A knows nothing about which one it's actually talking to. It's all handled by the routing that's part of the proxy configuration that's managed by the service mesh control plane. Now, if you want to dig more into containers, available to talk at the Unconference this afternoon. Thank you.